Today, we are going to be setting some boundaries for our stepper motor using a limit switch and Arduino. After you've done your first few projects with your stepper motor, the natural progression involves adding a limit switch. You can always have your stepper motor take, say, 200 steps this way, and you want it to perfectly stop there, and then make it take another 200 steps to here. But what you'll find is that it starts to travel a bit. Stepper motors sometimes skip steps. And I found periodically you have to readjust. And when you start your Arduino, this will start in a random position. So if you want to establish specific stopping points for your stepper motor, the limit switch is the way to go. I already have mine wired up and ready to go because I like to focus more on how to integrate the limit switches. But if this is your first time, I have a step-by-step tutorial that goes through everything from identifying your wires so you hook it up correctly to your motor driver. More importantly than that, setting the current limit for your motor driver so that way this thing doesn't suck too much current from your power supply, overheats, or worse, gets damaged. And then after that, how to hook it up to your Arduino and power it properly. Check out that tutorial. Link for that is below, and then jump back here and let's add some limit switches. I have 2 limit switches wired up and ready to go. And there's a few different varieties, but by far and large, they pretty much wire up and work the same. These little pin names are nigh impossible to read. You have to get the lighting just right. This first one on the right is C, or sometimes you'll see it labeled COM for common. And so whether you use this pin or that pin, they both work with the common. So it's a great pin to make your ground. Next one over is our NO for normally open. And that means there is no electrical contact between these 2 pins until the switch is triggered. And finally, for NC, that means normally closed. So there is electrical contact as the switch stands until it's triggered. Then it breaks the contact. So if this one goes to ground, which is the better pin to use for your Arduino projects? You can already see my preference. I like the NO because your project can run as normal. Your stepper motor is rotating until it hits an obstruction. And then you can stop it, you can change direction, or have it do other things. Let's get these wired up so we can get to our code examples. For prototyping purposes, I just have the wires wound up really tight at the pins. And because they're bare on the ends, an easy way to hook them up to your Arduino is to use quick connects like this. And on the other end, I can hook up little jumpers that can then go to the Arduino pins or the breadboard. So this purple one will be our signal line. And for that, I'm going to put this one into pin 7 of the Arduino. And then the ground, I'll hook up, moving him to the other side here, I'll hook him to the ground rail of the breadboard. And for the second one, same thing, except this time, this one will go into pin 8 and also the ground rail of our breadboard. And then we only really have 2 wires going into the Arduino. This first orange one here is our direction pin. So this controls whether the stepper will spin clockwise or counterclockwise. And then we have our yellow step wire right here, which tells the stepper motor to take each step. Let's go to the code. In this first example, we're just going to have the stepper motor do its thing. It's going to sit there spinning until whatever it's controlling hits that limit switch, and then we want it to immediately stop. Looking at this sketch, it's pretty short, and we're not going to use any libraries. We're going au naturel on this one. And the first thing I like to do is define my Arduino pin connections up here. This is totally optional, but believe me, this is a rather small project, and your projects will no doubt start to grow. They always do. They start shooting limbs. More often than not, you're going to have to change pin positions. And so rather than having to dig through all of your code to change pin number 2, it's nice to have one place to do it, and then you're set for the rest of the code. So for our direction pin for the stepper, that was on 2, and then the step pin on 3, and then we're just going to do the one limit pin here on pin number 7. And then here I set up two variables to help with controlling our motor. So the first one is motor speed, and you can change this to whatever you want to suit your project. For now, I picked 5,000 microseconds between steps. And of course, lower numbers is going to make it move faster. Higher numbers is going to slow it down. And then I wanted to set up a flag, a Boolean, and call it moving. So is the stepper moving? True or false? And we're going to start it with true because we just wanted to get going right off the bat. And then in our setup, I set the pin mode for the direction pin to an output because the Arduino is going to be outputting information to the direction pin so the stepper motor knows which way to turn. And same thing for our step pin, that's also an output. So that way the Arduino says, hey, take a step. And then for our limit pin, I set that as an input pull up because you'll notice we didn't include any pull up or pull down resistors with the limit switch. And the limit switch is like any other switch. It tends to float. So you either want to put a 10K pull down or pull up resistor, or if you want to keep your circuits a little more clean, you can use Arduino's own internal pull up resistor. So that's what we're doing here. And then first things first, let's set a direction. We're not going to mess around with changing directions just yet. So I'm going to set the direction pin to high. So high turns it one direction and low turns it another. So whether it goes clockwise or counterclockwise depends on how you have your stepper motor wired to the motor driver. And just to give me a little time to get over there to like prevent anything from going kablooey in case I wired anything up wrong, I'm giving myself 5 seconds before the rest of the program starts. So here in the loop, we've already set the direction, but no one's stepping on the gas. No one has told the stepper motor to take any steps because the first thing we want to do is check to see if that limit switch has been pressed, because maybe when your project starts up, it's already there pretty much at the limit switch. So we want to check that first. So if the digital read of that limit 1 pin is equal to low, because we're using a pull-up resistor, under normal circumstances, it's high. If it's depressed, it's going to be low. And should that be the case, if the limit switch is pressed, we want to set our flag to false. And you'll notice in this if statement, should the limit switch be pressed, there's no instructions in here telling the stepper motor to take any steps. So it's just going to sit there. And then here is where the good stuff is. So if the flag is set to moving, which we did all the way up here, we set it to true. So that's going to be its default state. And this is where all the stepping happens. So first, we're going to take that step pin and turn it high. So it's going to take a step. At what speed do we want it to take that step? Well, the motor speed, which we have set to 5,000 up above. Then we're going to turn that step pin low, meaning turn it off. So our stepper motor is going to just keep taking steps forward, and these two are going to toggle back and forth until it hits the limit pin. The second this goes low, then it's going to stay stuck in this mode and turn moving to false. There are no instructions in here to take any steps. We've hit the end of the line. Nothing's happening because I have to plug in our stepper motor. Oh, and it is going. It's a little loud because it is hitting and reverberating against the table, but it's doing its thing. Whatever it's controlling is moving. And I believe this may be limit switch number 1. We're about to find out. So now it's hit the limit and it stops. All right, I let go. And in the code, we have it to stay stopped because it's already hit the very limit of whatever range of motion. So as soon as you let go of the limit switch, you don't want it to just continue going off the track. So at this point, we can write code to make it do something else. Maybe it goes back, or maybe it activates a sequence of events for a prop or an attraction before going back, like opening a little panel and then shutting the panel. So let's involve this other switch here. He's been like hanging out on vacation. That's not allowed here. In this next example, I want to create kind of like a automatic camera slider. So it can start on one end and start moving down the slider, capturing beautiful footage until it hits a limit with a little limit switch. And then it's going to pause there maybe for like 5 seconds and then start traveling back. And it'll go back and forth between these two limit switches. So here, a couple modifications to the sketch. We still have our Arduino pin connections up top, and all I did was add our second limit switch, which was connected to pin number 8. And then we have our familiar motor control variables. So I'm going to stick with my speed of 5, kind of fast for a slow moving camera slider, but we're capturing really quickly. And our direction is set to true. So this should start rotating clockwise. If it's rotating opposite for you, then just take your motor wires and switch the pairs. And in this next block, we're going to track if we're ignoring the limit switch until it releases. Ignoring the limit switch? Isn't the whole point of putting limit switches is so things don't break? But think about it. Here we have our limit switch. The camera's coming towards it, and it'll trigger the limit switch. The limit switch will go low. That limit switch is going to stay low because the camera is touching it. So we're now forever stuck in this position. The camera is not going to go back. So at some point, say it counts to 5, it's got to ignore the fact that this limit switch is pressed and just start moving the other way no matter what until it hits the other limit switch, and then go through that same logic. So here I have ignore limit 1 and limit 2, and both are set to false because when the program fires up, I don't know where the camera is, so I don't want it ignoring any limit switches. And in the setup, all I did was add an additional pin mode for our second limit switch and set that to use the internal input pull-up resistor. To get things started, I have the initial direction set to direction, which we then set it to true up above, so clockwise. And our emergency 5-second delay in case I need to run and unplug anything. In the loop, we're going to start by checking 2 conditions. This if statement handles the first limit switch, and then this second if statement handles the second limit switch. And they only apply if we're not ignoring them. Because remember, we set the ignores to false. So we're not ignoring them. We want to pay attention to them. So if we are not ignoring limit switch 1, and the direction is set to true above, and it so happens that the digital read on that first limit pin, which controls the clockwise direction, all of a sudden goes low, it means that the camera has reached that first limit switch, and we are not ignoring it. So here, if you take a quick gander at the code, you don't see any stepping instructions. So the stepper motor is going to remain still. So this means that it did indeed hit limit 1. We want it to pause for a little bit, 5 seconds, which is right here. Then we want to reverse direction. So we're going to take our direction, which was set to true, and we're going to set it to not true, which is false. And then we are going to write our direction pin by that new direction, which is now set to false. We're also going to say ignore limit 1 to true, because this camera or this stepper is stuck on limit switch 1. If we don't start ignoring it, it's just going to stay stuck there. So once we know that the motor has stopped, it's ready to change direction, it's now going to ignore it. So that way it can start moving the other way. So say that this condition were true. That means this condition can't be true. Both limit switches can't be pressed at the same time if you only have the one camera going back and forth. So we're going to skip that for now. And after reversing, wait for the switch to be released. So what's going to happen is it's going to count to 5, and then the stepper motor is going to start going the other way. So the switch is going to be released, and that's going to start reading high again. So as soon as that happens, well, we're going to set the ignore limit switch back to false, because the next time the camera comes around, we don't want to be ignoring it. So as soon as the limit switch resets, we are going to reset our flag as well. And that stepper motor can proceed with the stepping. Now we have our camera going the opposite way, traveling towards limit switch number 2. So in that case, this will be true because we've never not ignored limit switch 2. It's still set as false from above. So it's going to come here and say, okay, we are not ignoring limit switch number 2. We are reading it. And it's going in the not direction. So direction of false means counterclockwise. And if it so happens that the digital read on that second limit switch happens to go low, we know it's been pressed. So we got to stop that camera. And you see that there is no stepping instructions here. So limit 2 has been reached. And we want to wait for 5 seconds. Camera's got to rest a little bit. And we are going to change the direction, which was not direction, to not of the not direction, which makes it true. All right. Coding can be so Yoda talk sometimes. It's like, not of the not direction you must go, young Padawan. So here we switch direction back to true. And because now the camera is stuck on limit switch 2, we have to ignore it, or else it's just going to stay stuck there. So we flip that flag to true. And then coming down here, this one is the one that has to do with limit switch 2. So if we are ignoring limit switch 2, which we are up here, and it so happens to go high because it was low, the camera starts moving and then it goes high. Now we want to set ignore limit 2 to false because we don't want to ignore it the next time. And then here, our camera goes from limit switch 2 and it starts heading back to 1. Where then the whole thing starts all over again with the ignoring and not ignoring and the direction and the not of the not direction. Our stepper is turning clockwise, so that camera on the slider is headed to limit switch number 1. And then it gets there. So I'm just going to press this down. And it's stuck there. So it's going to count to 5. And no matter what, it's going to start going the other direction and ignore this. Now, as soon as I let go, it's not ignoring it anymore. And it's traveling to limit switch number 2, which is over here. And our stepper camera gets there. It's going to count to 5 and start moving the other way. And it's just going to repeat this by itself. When you first plug in a stepper motor, it'll just start from where it stopped. So I unplug it, plug it back in. What if you need to start it at a specific point before your program even gets started? In this example, we're going to home the stepper motor before it gets started with the rest of the program. Sometimes you don't even need limit switches for your program, but you do need your stepper to start in a very specific spot, or whatever it controls needs to start at a very specific spot. So here with our pin connections, you can see I've dropped back down to using just our limit switch 1, but this doesn't mean that you can't use as many limit switches as you need for the rest of your project. And our motor control variables are pretty familiar. We're going to travel at 5,000 microseconds per step. And we're going to keep track of whether or not our homing is complete. So in the very beginning, we're going to assume it's not. So I'm going to set that to false. This setup should look mostly familiar. We have our pin modes again, but this time I'm also going to initialize or fire up our serial monitor so we can see when the homing is complete. To start the homing process, the first thing I want to do is print to the serial monitor that it's happening. And I'm going to also flip our direction pin to low. Low means that is moving counterclockwise, because in this example, I'm kind of envisioning that it's got to move counterclockwise to hit limit switch 1. And then once it's home there, then it can proceed clockwise. You can set this up however it works for your project. With the direction set, we need to start taking those steps back towards limit switch 1. So long as or while the digital read of that first limit switch pin remains high, keep stepping. So here is our stepper motor stepping, and it's going back to the limit switch. So long as it reads high, we know that it hasn't reached the limit switch. The second it does, that switch will go low, which means this while statement here will no longer be true. So it's going to jump out of this whole thing and go to the next thing, which is that homing is complete. So I'm going to print to the serial monitor to let me know that the process completed successfully, and also switch my homing complete flag, which was set to false above because we hadn't started this yet, to true. Now that we're ready to go, I'm going to change direction because we're going to want to go in the clockwise direction. So the direction pin goes from low to high. And before we start the program, let's wait 5 seconds. Otherwise, your stepper is just going to be done homing and then it's going to start. Now, usually that doesn't matter, but it's nice to have a pause just to double check that everything went right. Give you a little time to pull the plug if necessary. And then it's ready to start our main loop. And if homing is complete, which we did set it to true here, only then will it start taking steps. So if something went wrong here where it didn't quite depress the limit switch, this flag will never be reached. That's kind of another safety check before starting your main program. It's going counterclockwise, and I do admit it's going a little too fast for what I would use for homing, but whatever. This stepper is known for being our fast and furious stepper, so he wants to home real quick. And he's traveling towards limit switch number 1, which he has probably reached several times over now. But now it's been homed, and it's going to wait 5 seconds before starting the main program. And now you have 3 examples for using a limit switch with your stepper motor projects. And all the wiring diagrams and code for this project can be found on my website. Link for that is below. If you have any questions, feel free to post in the comments, or better yet, join my mentorship community, because every week we have live office hours, we have live workshops, as well as Arduino project challenges where we take all of the components and combine them to create something unique. I encourage you to join. It's an opportunity to talk face-to-face in a small group setting via live video chat. So link for that is below. All right, guys, we crushed it, and I can't wait to see what you build next. See you later.